there. Oh, let me stop my music. All right. So we have reason to celebrate tonight. We have finally acquired the mathematical tools to be able to figure out how to calculate a mortgage payment. So this is going to be exciting. We're going to have to put a lot of the things together that we've been learning about with present value and future value and having periodic investments. All of those things are going to come together, and we're going to come up with a formula for how much we will have to pay for a mortgage. Now, in the past couple of assignments, we've been looking at borrowing money and paying it back at a future date. So for instance, there were examples where we might borrow $10,000 and pay a larger amount back 5 years later. We pay it back with interest. But no one, no bank anyway, is going to lend you money and let you pay them back 5 years later or 10 years later or 30 years later all at once. What they want is for you to give them a little bit back every month. And we need to be able to calculate what that little bit is based on the amount that you borrow. Or conversely, if you know how much you can afford to pay back every month, you can then calculate how much it is that you could borrow. So hold on. We are going to figure this out, and I'm going to flip us over to a screen of graphs. Okay, so here's our screen of graphs. It shows us the answer to the problem. Now you may have a little bit of trouble of figuring out what the answer is based on this. So let's simplify for a few minutes here. Okay, so we have a lot of things going on in this graph. We have a blue curve, a green curve, and a red curve, right? So let me state what each of these are, okay? First of all, let me just get rid of the other curves. The blue curve. This is the curve that tells you what would happen if you borrow a certain amount of money and you just let it accrue interest over a time period. Okay, so right now it looks like the starting amount over here at time zero. So the horizontal axis is time and the vertical axis is amounts of money. So it looks like we borrowed $40,000 in this example. All right. If we look over at the sliders, our annual interest rate right now is set at 4.5%. That's annual, but that's going to be compounded monthly. So if we borrowed $400,000 and didn't pay it back, and 30 years later, so the black line over here is at 360 months. Okay, so if I change the time on that, the black line will move. So that's if I took a 5-year loan, the black line tells me how much I would have to pay back if I had waited for 5 years to pay it back. And I can keep going, 10 years, 15, 20, 25, 30. Now in the mortgage business, loans are usually either given for 15 years. You can say the amount that you'd have to pay back 15 years later looks to be just under $800,000, or a 30-year loan. All right, and it looks like if you took the 30-year loan, you would be up well over $1 million. Looks like somewhere a little bit more than $1.5 million that you would have to pay back 30 years later if you were to wait that long. Now you might say, well, why would I wait 30 years when I can pay a lot less at 15 years? Well, here's the other part of the problem. So the amount that you would owe is growing according to this blue line, and that is an exponential growth line. So we had worked with that. That was like a single investment in the bank that simply grows over time. In this case, it's a single negative investment because you're going to have to pay it back over time. You don't get to keep the money at the end. That's what you would have to pay. All right. Now, let's introduce the green line. Okay, so what is the green line? This is the line that would represent what happens if you were to invest a certain amount every month at the same 4.5% interest rate as the loan. Okay, so if we could invest it at exactly the same rate and we were to put in an amount, let me move my slider around. If I put in different investment amounts, we can see that we could save up different amounts of money. Okay. Now, if we're in the 15-year loan scenario, the key would be that we could save enough money. Let me move the curve up so that it would match, okay, with the loan, the amount of payback would be, okay. So if I could save up enough money by putting away a little bit every month, I would be able to pay back the loan right at the 15th year. You could pretend that you took the loan and then you walked into the bank with a briefcase full of money right at year 15 and gave them the money so that you have fulfilled your contract. Pretend things like they'll send bad guys after you if you don't pay. Makes it more interesting, but you will want to be able to pay that loan at the end of 15 years. Okay. Now, if the time frame moves out to 30 years, you can see the monthly payment. We can actually take the monthly payment slider and move it down. Okay. So there's some amount that we could save every month in our investment plan so that we would be able to exactly pay back the loan at the 30-year mark. Okay, we can see, looking at this, if we invest $2,000 per month, the A value right now is 2,000. The green line doesn't quite make it up to where the blue line is, so we would come up just a little bit short. If I slide the slider over just a little bit to 2050, we can see that we actually have a little bit of extra. So we could type in a value. I think it's somewhere in the middle of those two. So if I typed in that A is equal to $2,025 every month, wow, that looks like a really good match. So we're probably within a couple dollars of the amount we would have to save every month in order to be able to pay off the loan. Now let me introduce the red line. So the red line gets lower and lower. You can see that it starts at exactly the loan amount when our savings would have been 0, and it drops to 0 when our savings matches the amount of the loan. Okay. What the red line is the actual amount that you would owe the bank, because what you actually do when you save the money, when you're paying your mortgage, you're actually saving the money into your own loan. So the amount of the loan is dropping as you put the payments into it. So the red line represents what is left in the mortgage payment, or I'm sorry, in the, what you still owe to the bank, I'll say, at each given time. So hopefully at the end of 30 years, you owe the bank nothing if you planned everything out just right, okay? So there you have it. The red line is actually the difference. So it's the exponential growth minus the investment curve. And the reason we can use the same interest rate for both is because what you are investing in is your own loan. And eventually the difference between those things goes to 0 and you've paid off your loan. If it were a shorter time period on the loan, if we go back to 15 years, clearly $2,025 every month isn't enough to pay off the loan. So it's a lesser amount to pay back, but we would have to actually save more than $2,025 every month. We would actually have to contribute about $3,100 to the loan every month in order to pay it off in time. So while the total amount of payments will be lower if you take the 15-year option, the amount you have to pay every month is higher. So it might be harder to pay it off. So people make the decision all of the time whether they want to pay a larger amount back to the bank over a longer time period. Because if they take that option, usually the amount they have to pay each month is going to be lower. So let me pause this video, and actually I'll start another video after this.